Hello and welcome back. Last time was a great and quite long tutorial on the chi-square test. This time we'll make it short and sweet. We only have a few things left to cover off, and I'll just start off where we finished last time. So here we had the template that we created, or basically the Excel spreadsheet where we ran our chi-square tests. By the way, you can get the template as promised. It's in the course materials, just like you would download a data set. You can go and download the same way. You can download this template and use it in case you need it you need to check some things or run a chi-squared test in the future. And here we also ran the chi-squared test on this website. Over here you can see the link, and we were able to confirm that our results are valid. So this is just a quick way of running a chi-squared test without having to create everything in Excel. And what we're going to do now is we're going to finish off with the rules of a chi-squared test. Let me just find them. I will bring them up just now. And there they are. So the rules of a chi-squared test. These are important things that you need to abide by to make sure your chi-squared tests are running correctly, and the results that they're giving, you can actually talk about them and use them to back your analysis. So we're using the chi-squared test to back what we're seeing in Tableau, but you need the rules to make sure the chi-squared test is working properly. Number one, the probability of independence. This is what the chi-squared test is about. This is the essence, the quintessence of the chi-squared test. It basically tells you or helps you understand whether there is some sort of correlation between your outcome and a certain category or certain variable. So whether it's gender, whether it's age, whether it's whatever other variable, chi-squared will by default assume that there is no relation. So it's the outcome is independent of that variable, and then running a chi-squared test will tell you. So if the p-value is less than 0.05, that means that that is a incorrect assumption and that there is actually some sort of correlation. Number two, chi-squared test does not test for the actual relationship between variables. It can tell you if it exists or not, but it can't tell you what that relationship is. So you cannot use the chi-squared test to say that gender has a more significant impact on your outcome than, for example, age, or for example the balance on their account, or some other variables. You can't compare, you can't contrast or compare. You can only say yes or no. That's all the chi-squared test can do. So just make sure that you're using the chi-squared test for the correct purpose. You cannot use percentages. You need absolute values. As we discussed, you have to convert your table into the absolute values. Make sure you don't put percentages in. That's a common mistake people make. They put in percentages and then they run the chi-squared test. It'll give you a wrong result. Categories must be mutually exclusive. So you cannot have a category where you can be in one category and then you can also be maybe in the other category. They have to be separate. Like in our example, a person either exited or not. You cannot do both. So that's a very important assumption of the chi-squared test. Number five, never exclude one of the outcomes. Doesn't really apply in our case, but it's good to know about. Sometimes your data might have several outcomes. Like we have only two, yes or no. Did the person exit or did the person stay? But maybe you might have a different data set that might have three or more outcomes. I'll give you an example. Let's say you're looking at political preferences of people. And so your independent, also your variables that you know about the sample are like gender, age, affluence, how much money they have, what car they drive, things like that. And then your outcomes can be Democrats, can be Republicans, and can also be Greenpeace. So three different political preferences, right? And you can't be two of them at the same time. They're mutually exclusive because you can only vote for one. And at the same time, there's three of them. So what this rule is saying is that you cannot, if you have three outcomes, you should never exclude three or more outcomes. You should never exclude one of them. So you can't just run the chi-squared test for Democrat and Republicans if the way your sample is constructed that you had all three in there, because excluding one of the outcomes can affect the results of the chi-squared test. Having said that, bear in mind that you can exclude categories of one variable. Like in our example, we had three countries, right? We had France, Germany, and Spain. And what that means is that we can test we can run the chi-square test with all three countries and just decide whether country as a variable impacts the whether or not the person leaves. But what else you can do is you can completely forget about people who are from Germany, right? And you can just say, just take them out for a minute from your analysis and just think about people who are from France and from Spain. And you can compare those two against each other. So you can run a chi-square test just for the two of those countries. You just got to understand what the outcome will be. And in that case, the outcome will be whether or not there'll be a significant difference for exiting the bank, depending on whether you're from France or from Spain. So just those two countries. So you can do that. You can exclude different categories of one single variable. And finally, rule number 6, a minimum 5 observations in each cell. So that's an important rule of chi-squared test. If you have less than 5 observations in a cell, you can't run the test. You have to look for other tests that might be suitable to your situation. So we're done with the rules, and I'm going to give you a challenge to take away that you can work on in terms of running a chi-squared test. So here is our geography, right? So this is what we just talked about. It's in percentages, so let's convert it into absolute values. There's our geography in absolute values. And now let's create the observed table. That's the observed table. As you can see now, there's 3 categories on the in rows: France, Germany, and Spain. And there's still 2 columns: stayed and exited. And here's our expected table. Similar, right? So when you're going to be doing this, of course, you have to calculate the exited properly. In this case, I used 20%, but in reality, it's a bit different to 20%. So just use the same approach that we used previously. And that's it. So all you have to do is run a chi-squared test. I'll give you a few hints here. First of all, if you look back here, you kind of see right away that probably it looks like there might be some sort of correlation when you run it for all 3 geographies. So what that chi-square test will tell you is that what it'll probably tell you is that there is a dependency between the people exiting and which country they're from. And so that's hint number 1. So you kind of already know what the outcome should be. Hint number 2 is when you're creating your table, you just have to add another row here and just make sure that your calculations are correct when you're forming your expected table. Just make them similar to what you see here. It should be pretty straightforward, and that way you'll be able to practice creating a chi-squared test table and then just run the same thing here. So for the p-value, you have your actuals and your expected table. And finally, here's another hint. In case you get stuck, go to this website, vasarstats.net/newcs.html. So what this website can do for you is it will allow you to run the chi-squared test right here. So you just enter the data here, and you don't even have to enter the totals. So you just take the data as is. You just have to take these these cells, or the cells that we looked at in PowerPoint, and you just put them in here, you calculate, and it'll give you the p-value right away. It'll actually give you a lot more information which you can explore, but it'll give you the p-value so you can check that p-value against the one that you created in your Excel template. And so that sums it up for us for today. I hope these 2 tutorials were very insightful into chi-squared, and that now you're going to be very confident that what you're doing in Tableau, those tests, those very intuitive tests, that they are actually backed by hard statistics, and that you will always be able to stand your ground when you're talking to your manager, to your executive, or presenting to an audience. And I look forward to seeing you in the next tutorial. Until then, happy analyzing.